Okay, so here we're told the moon circles the earth once every 27.3 days. So that's the time it takes to revolve around the earth. So if I draw the earth in the center here and I'll label it E, and then I've got my moon, which is the one that's in motion, making a circular or close to a circular orbit around the earth, something like that. And I'll label that with a little m. The moon has some sort of velocity. It's trying to fly off at a tangent, and the moon is said to be exhibiting circular motion. We can assume it's uniform circular motion because, we can assume that it's basically a perfect circle where the velocity stays constant. Now, the interaction between the Earth and the moon is Newton's third law. The Earth is actually getting pulled to the moon with a force of gravity, and the moon is actually getting pulled to the earth with the same force of gravity. It's like this invisible string that's keeping it moving in a circle. The moon is the one that's accelerating. We're assuming that the Earth's acceleration, because its mass is so much larger than the moon, is basically negligible. We're only worried about the moon's acceleration. And because it's moving in a circle, the moon's acceleration is centripetal. So my net force for the moon is provided by the force of gravity. So my net force is ma, but because it's moving in a circle, we're going to replace a with ac. And for my force of gravity, we're going to use our bigger equation, gmm over r squared. Little m is the mass of the moon, big M is the mass of the earth. Now, the mass of the moon cancels because it's the one that has the acceleration. So the little mass is gone, and I'm left with my centripetal acceleration is gm over r squared. Now, r is the distance from the center of the earth to the center of the moon. That's the r we're actually looking for. So I get AC is gm over r squared, and I want to solve it for the radius of the orbit. What is the distance from the center of the earth to the center of the moon? Now they give you the period of motion, how long it takes to go around once. That's capital T. So T is 27.3 days. But you have to convert that to seconds. I'll let you guys do that. And then I'm going to use this version of centripetal acceleration. 4 pi r squared all over t squared is g m over r squared. Now, sorry, I've got my equation wrong. I'm just going to quickly fix that. My mistake. It's 4 pi squared r over g squared. Like that. Okay, we've made the correction there. Now, the most common mistake is that students want to cancel off one of the r's, but you can only do that if they're both on the top or both on the bottom. Here, if I multiply both sides by r squared, I end up getting r cubed on the left. So let's get all the r's to one side by multiplying it through. And then I end up with an equation that says 4 pi squared r cubed over t squared is equal to gm. And now the only thing left is for you guys to isolate r, get rid of the 4 pi squared over t squared by multiplying and dividing. And then you basically just solve it for r by taking a cube root.